Okay, Unit 13, we're going to start talking about polygons. A polygon is a many-sided closed figure made of a finite number of line segments. So that just means there's a number of line segments that we can count. Okay. Over here, this is a good example of a quadrilateral. Okay. And that's how we name or how we classify polygons based on how many sides it has. Okay. So over here, this would be quadrilateral because it has 4 sides. Lateral. And then if we're going to name it by its consecutive vertices, it would be quadrilateral A, B, C, D. Okay, I could have also said BA, DC. All right, it doesn't matter what order, as long as you're going either clockwise or counterclockwise when you pick those vertices. Okay, next, a regular polygon is a polygon in which all angles and all sides are congruent. Okay, so to the right over here, this would be, since it's got 6 sides, this would be a regular hexagon. All right. The interior angles of a polygon are the angles that are inside the polygon, formed by adjacent sides. Okay, so over here, if we look at, for instance, side BA and side AD, angle A here is an interior angle. Okay, we could have also looked at AB and BC. Okay, those two adjacent sides form that interior angle B. All right. Exterior angles, though, think about the exterior of your house, they are on the outside of the polygon. Okay, they are formed by one side and the extension of an adjacent side. Okay, what that means is, let's say I pick this side of this hexagon here. Okay, so this side and then the extension of an adjacent side here, angle D is an exterior angle of a polygon. Okay, and then we're going to talk about concave and convex. All right, concave polygons have at least one interior angle that measures more than 180 degrees. Okay, so in the figure to the right, angle B, that interior angle, if you'll notice, goes from here all the way around to there. Okay, since that angle is more than 180 degrees, this would be a concave polygon. But what you guys are probably most to seeing are the convex polygons. Okay, convex polygons, all of the interior angles measure less than 180 degrees. Okay, and that's what we will be working the most with. Okay, now when we name polygons, remember, it's based on the number of sides. So any 3-sided polygon is called a triangle. Okay, a 4-sided polygon, like a square or a rectangle or a parallelogram. Okay, those are all examples of quadrilaterals. All right, quad meaning 4, lateral meaning sides. Okay, 5-sided polygons are called pentagons. 6-sided are called hexagons. A 7-sided polygon is called a heptagon. Okay, that one's a little different, one that you might not be as familiar with. All right, an octagon, octo means 8. So a polygon with 8 sides is an octagon. 9-sided, this might be my favorite one to say, is a nonagon. If you think about how many years are in a decade, there are 10 years in a decade. So a polygon that has 10 sides is called a decagon. A polygon has 11 sides. It's called an undecagon. Okay, a way to think about that, uno means 1, and then deca means 10. 1 plus 10 is 11. Okay, that's just a little trick. 12-sided is called a dodecagon. Okay, and similar to the 11-sided polygon, dos in Spanish means 2. Again, deca meaning 10. So 2 and 10 together are 12. Okay. Now, anything that has more than 12 sides, so maybe it has 14 or 17 or 26, okay, we just say however many sides, we call that an n-gon, okay, and n representing that number of sides. Okay, so like I said, a 14-gon would have 14 sides. A 17-gon would have 17 sides. 82-gon would have 82 sides, okay? So I want you go ahead and in each of these examples down here, count the number of sides that these polygons have. Some are convex, some are concave, okay? But that doesn't mean that they aren't polygons, okay? And I want you to go ahead and practice naming those polygons based on the number of sides they have, okay? And we'll talk about those examples in class next time I see you.